I want to talk a little bit about how pandas and things in pandas like index alignment support the better writing of reports, support greater visibility into what that report is eventually going to do. Because it's not just churn that you have to contend with, it's also, I need to make a change here, but I have no idea what this report was actually doing in the first place. Why don't we take a look? When we have some data in pandas, we have usually like a data frame. Maybe we've loaded it from a CSV file or a pickle file in this case. And you can see here we have some projects that we were working on and maybe the revenue associated with each project for each quarter and the costs associated with that. And we can do simple analyses here, like we can sum up what the total revenue and the total costs are, or we could do a group by and sum this up per quarter or per project. And it's pretty straightforward. If it were the case that we wanted to model a scenario, maybe a growth scenario on these, what we could do is we could model the growth as a series. And here we can see this is the raw data. Here we can see these are our growth scenarios, quarter 1, 10%, quarter 2, 5%, quarter 3, 3%, and so forth and so on. You can see where Pandas gives us the ability to construct the building blocks of our scenario and then apply them, and to separate the construction of these from the application of these so that if somebody comes back and says, you know what, I need you to tweak what that growth is. I need you to say, you know what, if that growth is for anything after, let's see if I can do this correctly, for anything after May 1st, I want you to multiply that times 3. And let's do .lock here, and we'll do this from this to the end. There we go. And you can see we multiply that, and we can actually see what the consequence of that is before it gets applied, before we lose track in the depths of the aggregation. And so we could take this and make use of things like index alignment in Pandas. We take our raw data for project A, we take our growth information, and with Pandas, we can just multiply these together and get what the result is. What Pandas allows us to do is it allows us to take the idea of these complex loops that are occurring deep within these computational structures to just set up the computational structure with the columns and the row index to perform operations that automatically decide how to do that looping by index aligning. In the case of a data frame against a data frame, the index against the index, and the columns against the columns. In the case of a series in a data frame, the series index against the data frame's columns, which is why we have this ugly transpose in here. And to allow us to express this tersely in one line at the very end of our analysis so that prior to actually applying and generating the report output, we can look and say, is it running on the data that we want? Is it performing the scenarios that we want? Have we constructed these correctly? When we take a look at some data in Pandas, we may want to do something even more sophisticated with our analysis. We might want to have our data, and we might want to have different criterias for the revenue and the cost growth. And it's very helpful, rather than deep in some nested for loop where we're not going to be able to see, oh, we're using the wrong cost number here, or what's the cost number? We can actually see, oh, that's the revenue and the cost multiplier that we're applying for each quarter. And as I said, we can just apply this with a simple index-aligned addition and multiplication operation. And then as we need it, perform aggregations in order to do things like compute from this the profit, which would be the revenue plus the costs, or further group this by something like the project, and then get the profit per project, and there we go. When we take a look at something with when we take a look at scenario analysis using Pandas, we might discover that as a consequence of eliminating all of those layers of looping and all that ugly and complex looping, we're able to express really, really complex scenarios quite tersely and quite readably. Here, we have scenarios, a good scenario and a bad scenario, that involve different types of criteria, a growth in the revenue and the costs, and maybe some anticipation that projects may or may not be canceled or may not start. So what this says is, this is our growth of revenue and our growth of costs, and these are the projects that we believe will be started as of the first quarter, and these are the projects that we believe will be started as the rest, and of course the slice none means everything. And under the bad scenario, we can see we only specify the costs, so maybe the revenue doesn't change. At least we have that. And we can see that maybe it takes a little bit longer for some other projects that get started. We have another criteria here. And the application of these tends to be quite straightforward. Here's our data frame and our two scenarios. And we just loop over these. And what we can do, and let's go through this piece by piece. You can see that's our bad scenario and our good scenario. And all we're going to do is we're just going to take each one of the growth, add 1 to them, simple broadcasted or index aligned operation, and fill in a 0. So here you can notice that we didn't specify what the revenue growth is, but we can say, if you didn't specify that, we just assume that there was 0 growth. And then we can take our underlying data and we can, let's do this. Let's just double check one thing on our data. We have to just double check for the projects that we have here. We're going to have to do this a little bit differently. So let's do this block and see if this block works. Yeah, there we go. Here, what we're going to do is we're going to group by each quarter on each project, and we're going to identify if that project happened to be available or happened to be there for that quarter. And we can kind of filter our data down. And then we can basically use that to apply our growth computation. So here you can see we've done a very complex, and you can see it's a little bit making pandas a little bit ugly with one of these pieces here, but we could fix that separately. You can see here we have a very complex scenario, a growth on the revenue and the cost with some subsetting of this data. And it really just comes down to applying these operations in pandas in this fashion. You can see here we have this now aggregated. And of course, pandas is warning about one small thing that we did that's no longer something that is approved in pandas, but you get the general idea for what we can do. Maintaining visibility. One of the nice things about pandas and index alignment is we can set up these complex structures, have great visibility into what the report's going to do, and then at the very end, with just some arithmetic operations, some filtering, some group by, some dot lock operations, actually apply them to the report, such that this superficial level code retains all the flexibility of, oh, can you actually swap out with these growth figures over here? And all the visibility and all the flexibility of, oh, let's add another scenario. Let's add a little bit more of a structure to how we set up these scenarios, maybe another set of filtering, another maybe additive adjustment factor or whatnot.